Hello everyone, I am Rajeevsharma in front of. After the axial position of electrical dipole, now we discuss about a new topic, electric dipole in term of moment of force. In the previous class we are also study the moment of force, that is also known as torque. What is a torque? When the external forces is applied at any object is the moved around their own axis, that is known as torque, and the mathematical relation tau is equal to vector F into vector D. In our daily life, many example of the torque, to like as the tap. If the tap is open in anti-clockwise direction and closed in clockwise direction, and different application is also useful in the daily life, to like as the lock. When key is closed, then it will be direction is clockwise. When key is open, then direction is anti-clockwise. In same manner, we are also studying this chapter electrical dipole in term of torque moment or the moment of force. Once again we repeated what is the moment of force. If the external force applied at any object is the moved around their own axis. Now let us start on topic electrical dipole in term of moment of force. Let us consider an electric dipole is placed in electric field E, then it will be moved in clockwise and anti-clockwise direction. The separated distance we are also know that of the electrical dipole is 2L. Now it will be moved in sometime as the clockwise direction and sometime to be moved anti-clockwise direction. We know that the relation of the torque tau is equal to vector F into vector D. Equation first, we know that the value of electric field E is equal to vector F upon Q naught, and the value of force F is equal to Q naught E. Equation 2. We put the value of the force from equation first to second. Equation first, tau is equal to vector F into D. We put the value of E, vector F is equal to Q naught E. Tau is equal to QE into D. Equation 3. But we observe in the figure once again placed in electric field and formed an angle and observe the figure. Triangle AB sin theta is equal to perpendicular upon hypotenuse. The value of hypotenuse, it was the separated distance, will be represented in figure by the dipole moment Now we put the value AB is equal to 2L. 2L sin theta is equal to OB, that is also equal to the displacement. Now we put the value of displacement in equation 3. Now is equal to QE into 2L sin theta. We know that Q into 2L into E sin theta. We know that electric dipole P is equal to Q into 2L. Therefore, the value to be tau is equal to P sin theta. It is the component to be stabilized, the torque relation. What is the torque? When the external force applied at any object is moved around their own axis, that is known as torque. In given figure, we observe that an electrical dipole plus Q and minus Q at the constant separated distance 2L, and it will be moved sometime as the clockwise direction and sometime moved a anti-clockwise direction, and the relation to be stabilized tau barabar Pe sin theta. Electrical dipole. Now we applied the different cases for the electrical dipole. If the angle is formed between electric field and dipole moments, then the value of torque to be changed. In case first, when the theta is 90, therefore dipole is formed 90 degree with respect to electric field, then the value of torque tau barabar P, it will be max. In another case, case 2, when theta is equal to 0 degree, because the electrical dipole to be moved in the direction of electric field and its component is also stabilized 0 degree. Now the relation to be changed, tau is equal to P sin 0. The value will be 0. In case third, when theta is equal to 180, because the electrical dipole to be moved in opposite direction of electric field, and the mathematical relation tau is equal to P sin 180. We know that the value of sin 180 is also 0, therefore the relation of torque to be 0. It is a generally component of the electrical dipole in the term of torque. Once again we repeated what is electrical dipole. When two oppositely charged particles plus Q and minus Q are the separated constant distance, that is 2L, and all the electrovalent bodies also behave as electrical dipole. But in this term we are also studied to the electrical dipole in term of torque moment, because when electrical dipole is moved in the clockwise and anti-clockwise direction in the presence of applied external forces, in the presence of electric field, that is known as the electric dipole in term of torque relation or moment of force. Now we discuss about another topic, electrical dipole in equatorial